AB Calculus Notecard 63, Integration Properties. This is the 63rd video lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District, to develop the Notecard system. This is very much a follow-up lesson to number 62, which was the Fundamental Theorem of Calculus. So these are just some properties that we're going to look at personified in a few problems. One, if f is defined at x equals a, then the integral from a to a, because you might remember from the Fundamental Theorem of Calculus, we had integral from a to b, right? Remember that? Well, here, a to a, and where the constant a is the same number of f of x dx equal 0. So what that is looking like graphically is this. If you have a function like this, and you have a value a, this is f of x, you're essentially looking at an area of a line segment that's infinitesimally small, and thus we have a 0. 2, if f is integrable on the closed interval from a to b, then the integral from b to a f of x dx equals negative the integral from a to b f of x dx. So if you switch the limits of integration, you can switch the sign. 3 is f of integral and determined by a, b, and c, all closed intervals. Then the integral from a to c of fx dx equals the integral from a to b of fx dx plus the integral from b to c of fx dx. So what that looks like graphically is this. We have a function f of x here, and we have 3 input values here, a, b, c. So all this is saying is that this whole area here from A to C is equal to the sum of this area from A to B and this area from B to C, because those two areas will be comprehended in this whole interval from A to C. So that's really all that says. Okay, now a few problems that will make use of these properties. What are all the values of k for which the integral from -3 to k x squared dx equals 0? Well, we can go back here and number 1. If we have the integral from a to a f of x dx, that will be 0. So we know that if k, our upper limit, equals -3, then -3 to k, I'll just say f of x dx will be equal to 0, and x squared being f of x. And have we finished everything here? No, because it says what are all the values, and so we haven't really verified that that represents all the values. Now graphically, I think we could do that pretty easily, but I want to have us use the analysis here. So what we're going to say is, I'm going to work over here to the left, integral from -3 to k x squared dx is equal to, we have x cubed divided by 3, integrating x squared dx, and we're going to evaluate between -3 and k. So again, we're going back to what we looked at in the Notecard 62 lesson. And so what we're going to have is we're going to have big F of B minus big F of A. And what that's going to be is we replace x with k, so we have k cubed over 3 minus f of a. We're going to plug in negative 3 cubed over 3. So that's what we have. That'll be our integral. Now we're going to find where this integral is equal to 0. So working below here, we have k cubed over 3 minus, well, we have negative 3 cubed is negative 27 times a negative, so negative times a negative, so we have plus 27 thirds. It's going to be equal to 0. Okay, that's where our 0 comes from here. That's where we got our 0 from. Okay, and working below, if we solve for k, we're going to have k cubed over 3 equals negative 27 thirds. Multiplying by 3, we're going to have k cubed is equal to negative 27. And finally, I'm working to the right here, we're going to have k is equal to the cube root of negative 27. And k is going to be equal to the cube root of negative 27, which is none other than negative 3. And it's not going to be plus or minus because we don't have an even numbered root, we have an odd numbered root. So this will be our answer to problem 1. So basically we got the only correct answer right here at the beginning. But we had to go through the process to make sure we could do this. And graphically what this looks like is this. Okay, we have x squared, right? And so if we have negative 3 here and 3 here, we should see that the area under the curve is only going to add up. So there's nowhere else we can go to have this thing be equal to 0. Next, problem 2. If h of x equals the piecewise function 6 when x is greater than 1 and 3x squared when x is less than or equal to 1, then find the integral from negative 2 to 3 of h of x dx. So I'm going to write this up here as, just to split this up, the integral from negative 2 to 3 of h of x dx. And what we look for is our breakpoint here, and it looks like that 1 is our number of transition. So we can split up this h of x to be negative 2 to 1, and we look for the number that's less than or equal to 1, or the piece of the function. That's going to be 3x squared dx, and then we're going to have plus the integral from 1 to 3 of 6 dx. Okay, so let's go over this. What we have here is, I'm going to put the integral from 1 to 3 of 6x dx first, and do that as a separate piece. And for that, we get, let me make sure I get this right. I get it wrong a little bit. 6 dx. Okay. And for that, we get 6x evaluated between 1 and 3. And that's going to be equal to 6 times 3 minus 6 times 1. So that's going to be equal to 12. Okay, so this piece over here on the right, integral from 1 to 3 of 6 dx is 12. Now we're going to take this integral from -2 to 1, and I'm going to take the liberty of pulling this 3 out front like this, and we'll have x squared dx, and that's going to be equal to 3 x cubed over 3, and we're evaluating between -2 and 1. 3 over 3 cancel, so we get 1 cubed minus -2 cubed. And for this we get 1 minus -8, -2 cubed is -8, 1 minus -8, so we're going to get 9. So we will say, make a concluding statement, integral from -2 to 3, h of x dx equals 12 plus 9, which equals 21. And so there we have it. Next. 3, the integral from 0 to 1 of quantity 5 minus 3x times quantity square root of 1 minus x squared dx. So we got a real deal going on here. What I want to do is split up this integral from these different terms here. I want to go from 0 to 1, 5 dx minus, I'm going to put 3 out front, 3 integral from 0 to 1, x square root of 1 minus x squared dx. So this little piece here, 0 to 1, put 5 out front, dx is equal to 5x from 0 to 1, which equals 5 times 1 minus 0 equals 5. So we know this piece here is 5, the value. But now we have this piece here. And what we have is definitely a more complicated integral. And for that, I'm going to do a U-substitution. Going back to U-substitution, we're going to say let U equal 1 minus x squared. And therefore du is equal to negative 2x dx. And dx therefore is going to be equal to du over negative 2x. And so now we can substitute everything we want. We can substitute in u for this thing here. We can substitute du over negative 2x for dx. And I'm going to start that over here. So we're going to have negative 3, the integral from, now I don't have, we're going to reset our limits of integration, but we have x here, and we have square root of u, so I'm going to say u to the 1/2 power, and then we have, replacing dx, we have du over negative 2x. I hope that makes sense. So we have x over x cancel each other. And let's go ahead and we're going to need to change our limits if we need to. So these limits of integration are in terms of x. So we can say if x equals 0, u equals 1 minus 0 squared equals 1. So we're going to put 1 in the place here for x equals 0. So u equals 1. There we go, replacing the 0. Next, if u is equal to 1, u is equal to 1 minus 1 squared, which is equal to 0. So now we've replaced up here the b. So working below, what we have here is 3 halves. We're going to have u to the 3 halves. And we're going to divide by 3 halves, which dividing by 3 halves is the same as multiplying by 2/3. Okay. So we have from 1 to 0. And 2/3 over 2/3 cancel each other. So we have u to the 3 halves from 1 to 0. And that's going to be equal to 0 to the 3 halves power minus 1 to the 3 halves power, which is going to be equal to negative 1. So our answer is going to be, I'll just write answer 5, which is this value here, minus 1 equals 4. So that's it. Next, our last problem, if the integral from 1 to 10 of fx dx equals 4, and the integral from 10 to 3 of fx dx equals 7, then the integral from 1 to 3 fx dx equals, I don't know what. Well, what we can do, the way to work this out, if we could get integral from 1 to 3 of f of x dx plus the integral from 3 to 10 of f of x dx is going to be equal to integral from 1 to 10 of f of x dx. So we're already fortunate to be able to find out what these are, so we know that this whole thing on the right here, integral from 1 to 10 of fx dx, we just replace that with 4. Okay? The integral from 10 to 3 of fx dx equals 7, so therefore the integral of 3 to 10 f of x dx is going to be equal to negative 7. And for that we go right back here. Where do we see that? Yeah, right here, number 2. We're switching. Okay, so this thing right here, we're going to say is negative 7. And then we want to find what this is here. So this is going to be an unknown. We can call this x. X minus 7 equals 4. So x is therefore equal to 11. So therefore, integral from 1 to 3, f of x dx is equal to 11. So does that make sense? Yeah, if you switch this around. Going to the other side. 11 plus negative 7 equals 4. We put negative 7 because we switched this around. So that is going to be our answer. So some pretty good applications of the fundamental theorem of calculus involving U-substitution and our properties that we introduced here in this video lesson. Hope this has been helpful to you. Good luck, and thanks for viewing.